Hello, I'm going to be talking about polynomials today. So these topics are what I'll be covering in this video, and then I'll make a second part covering all of these topics. So first, let's get into what a polynomial actually is. The definition is a mathematical expression containing only coefficients and variables to non-negative integer powers. That just means whole number powers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on and on. So all of these are examples of polynomials. And this includes, so this 3 is times x to the 0. So this is x squared, x to the first, and x to the 0. And it's just, these are all polynomials. These are also polynomials. But some things you can use to describe polynomials is the number of terms and the highest degree power in the expression. So this one has one term, so it's called a monomial, and its highest power is to the 7th, so it's a 7th degree monomial. This highest power is x to the first and has two terms, so it's a first degree binomial. This is a 0th degree monomial. This, you look at the first term and you see x to the first, but the highest term is this term. So it's still a 2nd degree trinomial because of 3 terms. And this would be a 3rd degree binomial. Generally, this would be the standard form for a polynomial expression, where you start with c0 and x to the n, and you have more and more terms until you finally get to the last coefficient times x to the 0. And any of these c's can be 0 except for the first term. So this first c0, so in an nth degree polynomial, the coefficient on that nth degree term can't be 0, obviously, because then it wouldn't be an nth degree term. The main things to describe a polynomial are its degree, which is the highest degree exponent in the polynomial, the number of terms, and the leading coefficient, which is just this c0, so the coefficient on the highest degree term. So first, let's go over constant and linear polynomials. Constant polynomials are also called 0th degree polynomials, and they're always going to be monomials, just one term. So here is an example, f of x is equal to 1. So it's just constant. Y is always equal to 1, no matter what value x is, right? And if it was different, if it was 2, 3, 4, it would still be a straight line. It would just be at a different y value. Linear polynomials, these are first degree polynomials, and they can be monomial or binomial. Here we have a binomial. So the highest degree is the first degree. Using this, we can start to see some things we can find in polynomials. This final term tells us the y-intercept, and actually does it on this one as well. And if we solve for x, when the function is equal to 0, we can get an x-intercept as well. Next, quadratics. This is where you would normally start considering things, specifically polynomials. So there are 3 main forms that quadratics can take: standard, vertex, and factored form. So given this graph of a quadratic, different forms can tell you different information about it. This is what the standard form would be, x squared minus 2x minus 3. But first of all, this c term, or the minus 3, tells you the y-intercept. So here we see the y-intercept is -3. It can also tell you the vertex. So negative b divided by 2a. So negative b divided by 2a would be 1. So we would expect the vertex to be at x equals 1. And we see that this line x equals 1 does have the vertex on it. So that is standard form. Vertex form, this would be vertex form, tells you the location of the vertex. So h comma k is the location of the vertex. So 1 comma -4 is the vertex. And we see that there. And finally, factored form, because these are being multiplied, if either of them are equal to 0, then the function is equal to 0. So you can just set either of the factors equal to 0. So here, when this is 0, x is equal to -1. When this is 0, x is equal to 3. You see that those are the exact x-intercepts for this function. And then a is if there's a coefficient on this x, and it will be the same a if you transform it from one form to another. and it tells you how steep the slope will be. So a high value for a will have a very steep slope, a very sharp curve. Fractional value for a will have a very gentle slope. Quadratic factoring for polynomials. So first, just distributing. If you have two binomials, there's a way to distribute it. The most popular way is called foiling, which is first, outer, inner, last. So you'll multiply the first two terms, then the outer terms, and the inner terms, and then the last terms. And with this, you would result in this expression for the polynomial. Difference of squares. So if you see something where it's a square minus another square, you can always factor that. So if you have a squared minus b squared, you can factor that into a plus b times a minus b. There's also this difference in sum of cubes. So the general formula for the sum of cubes is if you have a cubed plus b cubed, you can factor that into a plus b times a squared minus ab plus b squared. And you can also have b be negative, and you can just use this formula, but there's also a difference of squares formula where it just takes that into account already. So it'd be a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Next, perfect squares. So if you have a binomial and you square it, so if you have a plus b squared, you will get this form, where you get a squared plus 2ab plus b squared. So if you see a polynomial in this form, then you can just factor immediately into a plus b squared. Finally, the quadratic formula. Given standard form, we can find where the function is equal to 0 at the x values using this formula. So negative b plus or minus the square root of b squared minus 4ac divided by 2a. So whatever this equals to is where it just tells us the x-intercepts. And generally this part is called the discriminant. This will tell you how many solutions you'll have. So if b squared minus 4ac is a positive number, then you will have two solutions because you imagine you're plus or minusing the square root of a positive number. If b squared minus 4ac is exactly 0, then you'll have one solution because plus or minus 0 is just the same thing as 0, right? So the only solution will be negative b over 2a. And finally, if b squared minus 4ac is negative, the square root of a negative number is not a real number, so this would have no real solutions, but it would have an imaginary solutions, and it would have two imaginary solutions in that case. So this discriminant tells you if there will be two real roots, one real root, or two complex roots. Finally, the leading coefficient. So generally, any polynomial, as x gets really, really big or really, really negative, then any polynomial can be approximated with just its leading term. And for a quadratics, so this would just be approximately a x squared as x gets really, really big or really, really big in the negative direction. And if the leading coefficient is positive or negative, greatly affects the end behaviors of the graph. So for this polynomial, the leading coefficient is -1, and the highest degree is even. That means that this term will dominate as x gets really, really big. So the end behavior of the graph will just be negative x to the fourth, which will tend to go in negative to negative infinity as both x gets positive and really negative. So if we imagine we plugged in x is equal to 1,000 for this, we would get negative a trillion minus a billion plus 6 million minus 7, which is like 1.001 trillion. So this is just approximately this first term, right? It's approximately negative a trillion. There's also even versus odd degree polynomials. So this one is even, and we see it tends to go in the same direction as x goes to negative and positive infinity, and that direction is determined by this leading coefficient. This is negative, so it tends to go negative in both directions. But if it's odd, then it will tend to go in opposite directions as x goes to positive negative infinity. So here, with x to the fifth, which is odd degree polynomial, as x goes to positive infinity, f of x also goes to positive infinity, and as x goes to negative infinity, f of x also goes to negative infinity. That's because this leading coefficient is positive. If it is negative, then it will flip and have a generally negative slope. So then as x gets really, really positive, f of x will get really, really negative, and as x gets really, really negative, f of x will get really, really positive. If you have any questions, please comment below and I'll try to address them. And I will be posting another polynomial video addressing those other topics very soon. Thank you for watching.